Hey guys, welcome back to math. Today, we are going to focus on finding a more efficient tool for solving fraction multiplied by fraction. Like I said the other day, I am tired of counting these little tiny boxes. Heaven forbid if yesterday when you did this problem, you did 8s by 8s, because then you had to count all these little tiny boxes. Oh, what a nightmare that would be. Because there's like 64 boxes in this little thing. And that sounds miserable. I don't want to count that. You don't want to count that. That is not efficient. Efficient. Fast, easy, gets you the right answer. Is it fast to divide up and count all these little boxes? Not really. Is it easy? Yeah, absolutely. Super easy to count little boxes. Is it going to get you the right answer? Hopefully. If you count too fast or your lines aren't straight, you could easily get the wrong answer the smaller these boxes go. Now, when you got something like this, right, not so bad. There's not that many boxes. This is starting to get a little tiny and it's not as efficient anymore. So today, we're going to look at a more efficient tool for solving it. I'm going to bring this back. This is from math earlier. And I asked you to take a look at these equations and to see if you noticed anything about the products and something about fraction versus fraction. Today, I want you to look at these same equations, but I want you to take a look at the problem versus the answer. Do you think there's anything we can do with this equation where we could solve it without having to use little teeny tiny squares? Take a minute and see what you notice. If you need more time, please pause. But I think a lot of you have started to notice that there's some multiplication we could be doing instead of counting boxes. So let's see if I point out what you see, and if we're right, we're going to do some practice today to see if it always works. So if I look here, we'll start with this one. 1/2 times 1/2 equals 1/4. In adding, I can go straight across, assuming I have the same denominators, right? So 1 plus 1 would equal 1, 2. This is multiplication. So 1 times 1 does equal 1. Let's see if it works for the rest of them. Does 2 times 2 equal 4? It does. Okay, well, let's check the next one. I have 1 times 1 equals 1. Nailed it. 2 times 4 equals 8. Yep. Then 1 times 3 equals 3. 4 times 4 equals 16. Oh, look, 4 times 4 equals 16 again. 1 times 1 equals 1. 1 times 3 equals 3. 2 times 4 equals 8. So far, at least with these equations, it seems as though we can multiply straight across, numerators with numerators, denominators with denominators, and we'll end up at the right answer. Today, you're going to use your journal to record our thinking and all of our discoveries. We're going to see if this is always true. Let's get to it. So, today what I have for you are some different cards. So you can just look at what I have and we'll record our thinking in the journal. So here's a 1/2. And we'll multiply that by a 1/2 just for easy peasies. So, 1/2, right? 1/2 is blue. 1/2 is yellow. And if I put them together, this is what we've been doing with our squares. So 1/2 times 1/2. So what should be able to happen based off of the equations we just looked at, if I multiplied straight across, 1 times 1 equals 1, 2 times 2 equals 4. What I should be able to model over here is the same thing. It looks a little bit different because there's two colors. I wanted you to be able to see this half and this half. When I lay them on top of each other, I now see 4 different colored boxes. I see a green, a blue, a yellow, and a white. So there are 4 boxes. And what you're looking for is where they overlap, where they turn this green color. And in this case, there is only 1 green box. So our answer is correct. But these are with those small, easy fractions. We've kind of already figured out that those work. Our question is, what happens when I start pulling out some of those weird, bigger fractions? Like, what happens if I do 1/2 times 6/8? Here's our 6/8, right? 1, 2, 3, 4, 5, 6, 7, 8. 6 of them colored in. So what happens if I do 1/2 times 6/8? Remember, with multiplication, I could switch that. I could say 6/8 times 1/2. It's going to get me the same place. So, if our theory on this math doing is correct, I should be able to go 1 times 6 is 6. 2 times 8 is 16. And when I put the yellow piece on top of the blue piece, we should say 16 groups, and 6 of them should be green, if we're right. Let's see what happens. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Nailed it. And now, 6 of those should be green. 1, 2, 3, 4, 5, 6. So far, our theory is working out fantastically and is much more efficient than counting the boxes. But let's pull out a different fraction. We haven't done anything with tenths. Here we go. 4/10. So 4/10 times 2/5. I'm trying to pull fractions out of my decks of cards here that we haven't worked with, so we can see if it really truly does work. So let's see. If it works, 4 times 2 is 8. 5 times 10, 10 times 5 is 50. Holy smokes, can you imagine counting 50 boxes? How inefficient and what a time suck. That would take forever to count that many boxes, let alone draw them. Because think about it, on a test, when have you ever been given all these things, right? You'd have to count all those boxes, you have to draw all those boxes. Boy, that sounds like a nightmare. But let's see if we're right. So here's our 4/10. Here's our 2/5. If I lay it on top, we should have 50 sections total and 8 sections that are green. Whoo, that's a lot of little boxes. So we know there's 10 in this row, right? Because of the card underneath. So 10, 20, 30, 40, 50 boxes. Got that right. 1, 2, 3, 4, 5, 6, 7, 8. It's working, guys. And this is going way faster. All right. Time for you to do more work and me to do less work. So now let's do one where you do it. Okay, you're going to model this time. So we're still going to do 4/10 because that's what we have here. And you can put yours in a whole different, you don't have to make yours match mine necessarily, but I do want you to have all of these equations. So I want you to do 4/10 times 3/6. Pause here, solve it using our more efficient method of multiplying straight across, and we'll see if you get it, if our theory still works. All right, did you get it? I'm going to check the math with you before we put the parts together. So 4 times 3 is 12. 10 times 6, 60. Again, look at all, that's a crazy amount of boxes. I don't want to count all that. I'm far too lazy. All right, 4/10 times 3/6. We should have 60 boxes and 12 of them should be green. You ready? Oh my gosh, look at all those boxes. That's nuts. Okay, we know there's 10. So 10, 20, 30, 40, 50, 60. Nailed it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Working out pretty well. Let's try something bigger. I can go all the way to 12ths. Let's do 7/12. And we'll do it against a little bit of an easy one. Oops. So 7/12 times 2/3. Pause. Solve that. We'll see where we land. I just thought about something. So far when we've been multiplying fractions, we've been doing area. And area requires a units squared. Inches squared, feet squared, yards squared, whatever it is. We are just multiplying fractions here. We're not finding area, which is why none of these have a unit squared. You only need to have that if you're actually solving for area of something, right? The space inside of something, but we're not doing that. We're just multiplying fractions. So like 7/12 of a candy bar and 2/3 of the group eats it. How much candy bar are they eating? Kind of thing. We're going to work with story problems tomorrow, but I just wanted to put that out there, which is why none of these have, a unit squared on them, because it's not required. We're just multiplying fractions for practice. Okay, so cut back to 7 times 2 is 14. 12 times 3, so 12 and 12 is 24, so 36. 36, not so bad, not quite a million boxes, but still, like, I don't want to count 36 boxes. So we should have 36 boxes, and 14 of them should be green, if we did it right, if this theory continues to hold, which so far it has, so I'm feeling pretty hopeful. All right, so I still don't want to count it, so I'm just going to model it. Each one of these is 12, right? We should have 3 groups of that, so 1, 2, 3, which we do, so 36. And then 14 of them should be green. I know that this is 7, because the card tells us, right? That's why it's colored. And there's 2 groups of that 7. 1, 2, 3, 4, 5, 6, 7, so 14. So much faster than drawing and counting, guys. I'm so excited. All right. We got time for a couple more. So let's do a real humdinger. Let's do a big one. 9/12. 9/12 times 9/12 I'm just going to do a random flip here. It says 8/10. All right. You solve that one first. All right. 9 times 8, 72. 12 times 10 is 120. Can you imagine counting 120 boxes? 120 boxes. 120 boxes. That's crazy. I don't want to count 120 boxes. Or 72 for that matter. That's a really high number too. So let's see what happens. Here's our 9/12. Here's our 8/10. We should have 120 boxes. 72 of them should be green. Holy smokes, guys. That's so many boxes. Can you see that? Like, I think the light may be cutting it out, making it less dramatic for you than it is for me. There you go. Look at all those boxes. Holy smokes. But guess what? Our math is right. This is just showing the same thing that we did. All right. Last one, and I'm going super big. I'm going 9/12 by by 10/12. 9/12 times 10/12. Solve that one. All right, 9 times 10 is 90. And 12 times 12, 144. That's crazy. I don't want to count 144 boxes any more than I want to count 120 boxes. But let's see. Okay, so here's our 9/12. Here's our 10/12. Holy smokes. Look how tiny those boxes are. Now imagine them being on your worksheet, like from yesterday. Look how tiny 64 boxes was. Now try putting 144 boxes. That would be so tiny. That would be so easy to get the wrong answer because they're so small. Look at how big. Here, I'll zoom out so you have to see how big these squares are compared to my paper. Like, these squares are about 1/4 of my whole notebook paper. And those are still really small. We don't have space to be doing that kind of math. So, which is why we need this more efficient tool. So I'll zoom back in so you can see again. That would be the reason why. And just because I have a couple more minutes, I'm going to show you the biggest one that I can make off of our squares, which is with 12/12. And we'll do 11/12. Are you ready? Look at how many squares are going to be here. Look at that. That's nuts. That is absolutely crazy. That is so many squares. Nobody wants to count that. So now we have a more efficient tool for solving fractions times fractions. And that is to multiply straight across. 9. Now I can do any fraction I want without needing any kind of cards. So 9/13 times 2, I don't know, thirds. Right? Any of these fractions I want, and the math is going to continue to be the same. I'm going to do 9 times 2, 13 times 3 to get my answer. Good work today. You are going to work on page 187 in your workbooks called More Fraction Multiplication. Again, remember, you have to do the independent work because that's the only thing that your teacher can grade. So make sure to do that, and I will see you tomorrow with another video. Bye, guys.